The idea of CubeSat was conceived in 2007, and it was conceived under the guidance of Engineer Rahman, our Vice Chancellor. All over the universities, access to space was a big problem. The reason was that it was not affordable. So in one of these Stanford University professor came up with a standard so that the universities can have an affordable access to space. And because of that, a lot of universities have started making CubeSats, and this is our idea at that time to pursue this particular standard.
Basically, ICUBE is a small satellite, a CubeSat, where the satellite is in cubic form. Each dimension is of 10 centimeter. It's a model. It's a replica of CubeSat. This satellite has every subsystem that a bigger satellite has. For example, it has a power subsystem. It has a transmitter that transmits the data to the ground station. We have a small camera. And the solar panels are mounted on the faces so that the batteries can be charged whenever needed.
Can you teach it?
This is a very big project for a university in Pakistan to design a satellite and to test all the subsystems to get it launched to space and then to receive data from the satellite. So we had to involve people from every discipline. For example, people who have their expertise in power subsystems, in power, and people from the communication background, people from aerospace background, people from the materials background for the testing of structure, and people from imaging background for the imaging payloads.
I was involved in the ground station team. Actually, my duties were basically to automate the ground station and to make different softwares which could actually track the satellite, which specifically ICUBE, and then download the data from the satellite, and then later on save that data on the computer, and on the later stages if you can actually process it.
Well, ICUBE-1 contains two dipole antennas that are used for transmission and reception. One antenna operates in the UHF band and the other operates in the VHF band. Before the launch, the antennas are stored in the ICUBE, and which is held together with a dynamo wire. And once the satellite gets separated from the launch vehicle, the dynamo wire gets burned using some heating element, and then the antennas are deployed.
Ground station is actually it's an earth station where you can actually get the data from the satellite. So if there is a satellite passing over the ground station, you can download the telemetry or you can download the data from the satellite and store it with you in the ground station, and later on process that data with you.
What was it? IST ground station is a GENSO compatible earth station. It operates in VHF, UHF and S band. It is one of the 104 earth stations in the VHF, UHF band around the world which are operating in universities, and it is one of the 39 stations which also has the ability to operate in S band. So this GENSO compatible earth station allows in future for us to interact with other earth stations and to track ICUBE through other earth stations around the world, and similarly the other earth stations can do that with our earth station. This is compatible to our ICUBE-1 earth station. It will be used for telemetry, getting health data from the satellite, and it will be used to do telecommands to the satellite, and do all the test data that we get for ICUBE-1 after its launch will be done through this earth station.
Control, we don't have an actuator inside the satellite. What we are doing is we are controlling our satellite using a magnet, and that magnet will align itself according to the magnetic field of the earth. Okay. And with this we will be having an ease that if there is some problem with the actuator, that problem will not occur. So that would be an ease in order to adopt this scheme. The images of Earth is only possible when it would be looking to the upper hemisphere of the Earth, because in that's the only position in which the satellite would be pointing towards the Earth. Means the camera would be looking towards the upper hemisphere of the Earth. In the ICUBE 2, we are planning for an active attitude control. In the active attitude control, we will be having the actuators. Along with that, we would be having a computer which will be controlling the attitude control of the satellite in order to take images of the Earth.
Okay, ICUBE 1 will be launched via Denver launch vehicle from Yasny launch base in Russia. Denver is basically a converted ICBM, and that's why it will be launched from a silo, which is a underground sort of launch pad, and ICUBE will be placed on the top of that launch vehicle, which is basically the third stage. And after the separation of that third stage, ICUBE will be released from the UNISAT 5 satellite, which is an Italian satellite, and it is carrying the ICUBE. And after the separation of that UNISAT 5 satellite, ICUBE will be deployed from that UNISAT 5 satellite, and then it will reach at its desired orbit, which is around about at an altitude of 600 kilometers, and then we will able to track that satellite via our own ground station.
With the launch of ICUBE 1 on 21st November, IST will become the only university in Pakistan to have its own satellite. The satellite built in IST and launched through the Danipur 1 launcher. It will be the first university to have its own satellite. And we are very proud that the concerted efforts of the students and faculty and the leadership of IST resulted in this major achievement here at the institute. This was accomplished in a very short span of time, and we look forward to developing this second version, which is 2U satellite.